Hello everybody, I am currently studying in 3rd year in SRM Institute of Science and Technology. I am pursuing my BTech in Biotechnology. Today we will be conducting the second experiment of our Biochemistry lab, that is measuring pH using pH meter. A pH meter is used to measure the electrical potential across a pair of electrodes. You dipping the pH meter in a solution. The measurement of pH is done by using a pH meter that is sensitive to hydrogen ion concentration.
This experiment requires pH meter, 1 molar NaOH, 1 molar HCl, distilled water, 100 ml beaker, a rod, 10 ml beaker and samples. Our first sample is tap water. Let's measure the pH of tap water. As you see, the pH of tap water is coming near to 7 since it's a neutral sample. Now we will slowly add 1 drop of HCl. And we'll mix it using a rod. Again we will conduct the same and measure the pH of tap water. The pH of tap water now has reduced from 6.7 to 6.4. Why did this happen? This happened because we added 1 drop of HCl. Once you add a drop of HCl, the hydrogen ion concentration in the tap water increased, which would make it more acidic and thereby reducing the pH. Continuing the same, let's add 2 drops of HCl. Again, we'll mix it using a rod. We'll measure the pH. As you can see, the pH again reduced, that means it's become more acidic. Finally, we'll add 3 drops of HCl and see what happens. Again the same procedure, we'll mix it with the rod. As you can notice, the pH is now reduced from 7 to 6.1 after adding an enough concentration of HCl. This means that we made the tap water acidic from neutral. Let's rinse this. Moving towards the next sample, our next sample is Coke. Coke, as mentioned, is a colored soft drink. We will first check the pH of Coke. So Coke is acidic and thereby, as you see in the pH meter, it has a pH of 1.5. Whereas tap water was neutral, therefore it had a pH close to 7. Now we'll add HCl, 1 drop of HCl, and see what happens. Again mix it with the rod. Take your pH meter. As you can see, the pH reduced. This is because on adding of HCl, the hydrogen ion concentration increased and therefore it became more acidic. Let's do the same by adding 2 drops of HCl. Now we'll add 2 drops of HCl. Mix it again. Let's check the pH. As you can see, the pH is decreasing for the same reasons as mentioned earlier, since the hydrogen ion concentration increases and it's becoming more acidic. Finally, let's add 3 drops of HCl. Mix it again. Place the pH meter. From 1.4 it has come to 1.37 and it's become more acidic. We'll rinse the pH meter. We'll wash our rod. Moving towards the third sample, that's Sprite, non-colored soft drink. Again, we will check for the pH of the soft drink. So the pH of the soft drink is 2.5. This means that it is acidic in nature. Now we'll add 1 drop of HCl to check what happens. Mix it well. Check for the pH. As you see, there's a slight decrease in the pH. Once again, because the hydrogen ion concentration increased by adding HCl and therefore it became more acidic. Let's do the same by adding 2 drops of HCl. Mix it well. The pH further decreased, making it even more acidic. Finally, let's do the same by adding 3 drops of HCl. Again, the same procedure. Mix it well. Let's check for the pH. Overall, from the standard pH of 2.5 of the soft drink, by adding the drops of HCl, we brought it down to 2.25. Once again, because the hydrogen ion concentration increased as we kept on adding HCl, and therefore it became more acidic. We'll rinse the pH meter, wash the rod again, and move towards our last sample, that's ethanol. We take our pH meter, check for the pH of ethanol. So the pH of ethanol is 3.34. It's acidic. Now we'll add 1 drop of HCl. Mix it well. Rinse your pH meter. As you can see, the pH from 3.4 reduced to 2.4 because the hydrogen ion concentration increased. Now we'll do the same by adding 2 drops of HCl. Mix it well. The pH further reduced. Finally, let's do the same by adding 3 drops of HCl. Let's dip the pH meter. It's reduced, the pH is reduced to now 2.14. This means that it's become even more acidic than what it was earlier, again due to the increase of hydrogen ion concentration. Now we'll add 1 drop of NaOH to tap water to see what happens. We'll mix it well. As you can see, the pH increased from a neutral to 10. This means that it became basic. The reason for it becoming basic is that once we add NaOH, the concentration of OH minus ions increases, which in turn makes it more basic in nature. Let's do the same by adding 2 drops of NaOH. The pH further increased. Now the same with 3 drops of NaOH. As you can see, the pH further increased and it's become further basic in nature. Moving towards our next sample, that is Coke, colored soft drink. We'll rinse our rod as well. We'll add 1 drop of NaOH. Mix it again. Check for the pH. The pH is 1.75. Let's add 2 drops of NaOH. The pH increased from 1.75 to 2.17. showing that the OH minus ion concentration is increasing and therefore it's moving towards basicity. Let's add 3 drops of NaOH. Mix it well. Let's just add 1 more drop. As you can see, the pH increased from 1.75 to an overall of 2.74. Though it is still acidic in nature, but this shows that on adding NaOH, the OH minus ion concentration increases. Therefore, it goes towards basicity. Moving towards our third sample, that is non-colored soft drink, which is Sprite. Let's rinse our rod. Let's add 1 drop of NaOH. Let's mix it well. Now we'll check for the pH. The pH measured here is 2.73, 71. Let's see what happens when we add 2 drops of NaOH. Mix it well. Dip the pH meter. The pH from 2.71 went to 3.05. That shows that it's becoming more basic. Let's add 3 drops of NaOH. Dip the pH meter. As you can see, the pH has become 3.34. Not that much a difference. Let's just add 1 more drop and check what happens. The pH now has become 3.48. This means that it's become more basic in nature as compared to what it was earlier by adding NaOH. Our final sample is ethanol. Let's rinse our rod as well. Always remember to rinse the pH meter and rod before moving to your next sample. Let's add 1 drop of NaOH. Let's check for the pH. The pH is 4.07. Let's see what happens when we add 2 more drops of NaOH. Again, mix it well. As you can see, the pH is increasing. It's become 5.2, 5.37. Finally, let's add 3 more drops of NaOH. Mix it well. Check for the pH. It's gone to a 7.2. Okay. it's gone to a 9.1. This shows that it has become basic in nature by adding NaOH, since the OH minus ion concentration is increasing. At the end, we rinse our pH meter. We rinse our rod. And now we come to the end of our experiment.